Hey everybody, today I wanted to briefly talk about a cool new tool I picked up off the internet. It was cheap and it's actually pretty cool. It's this device right here. This is advertised as a USB charging tester or a charge doctor, stuff like that. I got this off AliExpress and it was, I think, like $4 and really fast shipping. Um, what it does is it allows you to connect a USB power source and an output, like the thing you want to charge or power up. And what it's going to do is measure the amperage and also the amperage over time. And this can be really useful for profiling power consumption on custom devices, such as this thing right here. This is just a little prototype I'm making for a mailbox lid detector. And this is an ESP8266 Wemo D1 Mini. This connects to Wi-Fi and sends a notification to my phone every time this switch is pressed. So every time my mailbox lid opens, I get a notification. And this is geared to run off of 3 AA batteries. And what I want to know is, how long is the battery going to last? And to know how long the battery is going to last, you need to simply measure its amperage consumption over time or in different states. So here's the reading here for amps, and here's the reading here for time. And that translates, like here, let's look at the screen for a sec. I'm not doing a great job of explaining this. Focus. So the measurements we get is volts and amps, time, and then that is used to calculate watt hours and amp hours. So right now you see it's registering at 5 volts because I've got a 5 volt USB supply. USB is 5 volts, generally speaking. You'll notice amps is 0 because there's nothing actually plugged in drawing anything. So now I'm going to go ahead and plug this USB port in. You can now see that 0.28 amps are being consumed, and you can see that the timer started right here. So now, over time, this amp rating is going to change depending on what the device is doing. Let's see, if I press this, you can see it spiked up to 0.76 amps here. And now it's connecting to Wi-Fi. It's when it's blinking, it's in a setup mode. That's the program I wrote. And when it's in a setup mode, it has a real-time server stood up. So it's going to draw as much battery power as it needs. Looks like 0.07 amps. After a while, there's an idle timeout, and this device goes into a deep sleep. And I can see that when it's in a deep sleep, it's using much less power. It's using 0.003 amps. So that's great. So now, if I leave it in a deep sleep, presuming it's 0.003 amps the entire time, I can do some math, or I can let this thing do it for me. I could maybe leave this plugged in for an hour, and this is going to give me the average milliamp hours used. So anyway, I thought that was a really cool device. I want to show it off, and I wanted to point something out that I didn't realize when I was first looking at this device. This is advertised as a USB tester, and that kind of implies that it's a 5-volt tester. But when you look at the specs for the product, it can actually read between 3 and 32 volts. It can read up to 5 amps, and that equates to 300 watts. So that's a pretty capable tester, and it can do stuff way outside of the scope of what USB would do. But it's just a USB input and output. So how do you hook other things up? Well, they, on the same store, they sell these connectors. There's one male USB to positive and negative alligator clips. Sorry, one female, and then there's one male USB connector to alligator clips. So now you can imagine, now you can connect all sorts of different power sources. So here I am going the regular 5-volt USB to alligator outputs, which I could now use to like clip on wherever appropriate for electronics. But what about the inputs? By the way, there is no input or output on this. You could feed power in from either side. So I'm going to use this one. I'm going to plug this in, and I'm going to connect it to a 9-volt battery. So the clips definitely come in handy for that. And as you can see, the device boots up and it's reading 9 volts. Pretty cool. And here is a slightly used CR2032, which is a 3-volt battery. And you can see, once again, it boots up. It may not be quite as bright, but you're seeing, oh, it's like 3.4, 3.5 volt. Awesome. This device plus a 2-pack of these USB kind of breakout cables came to under $10. So highly recommend this device, especially if you're going to be profiling battery operated electronics. Thanks.